Rainbows, full of different shades of color, so beautiful that I have to take out my phone to snap a picture. However, for some people, this rainbow may not be so impressive. Around 1 in 12 men and 1 in 200 women have color blindness, or the more accurate term, color vision deficiency. This is where people have difficulty telling the difference between certain colors. Now, to fully understand how color vision deficiency works, we must first understand how regular color vision works. People with regular color vision are called trichromats. This is because we rely on 3 different types of special cells called cones to see color. When light hits an object, the object will absorb most of the light and reflect the rest of it. The reflected light will enter the human eye and hit a layer at the back of our eye called the retina. Inside the retina are 2 types of light-sensitive cells called rods and cones. Rods allow you to see in low light conditions, whereas cones contain color-detecting molecules which allow you to see color. We have 3 types of cones: red, green, and blue. When you see a color, each cone sends its own distinct signal to the brain. For instance, you see this banana. The light reflected by the banana activates both the red and green cones. These cones then send a signal to your brain, which processes the number and types of cones activated and the strength of the signal. From this information, it can work out that the color you are seeing is yellow. The different combinations of cones activated and the strength of their signal allow you to see a million different shades of color from just 3 different color informations. But what happens when one or more of these cones stop working properly? Well, it could lead to color vision deficiency. The most common and mildest form of color vision deficiency is anomalous trichromacy. People with this have all 3 types of cones, but one of them does a slightly subpar job. A more severe form is dichromacy. This is where one of the cones do not function at all, and so you can only see the colors perceived by the 2 functioning cones. Anomalous trichromats and dichromats can be further subdivided into red-green color blindness and blue-yellow color blindness. Red-green color blindness is the most common form. This is a deficiency in either the red cones or the green cones. People with this condition have difficulty distinguishing between reds, greens, browns, and oranges, and instead they will see the world like this. Blue-yellow color blindness, on the other hand, is quite rare. People with this have a deficiency in the blue cones and have difficulty distinguishing blue from green and yellow from purple, and instead they will see the world like this. The most severe and rarest form of color vision deficiency is monochromacy. This occurs when 2 or more cones stop functioning. People with this see the world as shades of black, gray, and white. For most cases, color vision deficiency is inherited. The gene that causes red-green color blindness specifically is located on the X chromosome. And since it is a recessive gene, males are more likely than females to have red-green color blindness, as males only have 1 X chromosome, so if they receive the defective X chromosome from their mother, they will have the condition. Whereas females have 2 X chromosomes, so both X chromosomes must be defective for them to have the red-green color blindness. Blue-yellow color blindness and monochromacy, however, are passed down on other chromosomes, so they affect males and females equally. So, if you see a 6 in the center, you probably have regular color vision. But if you're thinking that that's absolutely ridiculous because there's clearly no number, you may want to go to the eye doctor to get officially tested.